Thank you very much, Greg. Hello, everyone, and it's really great to be talking to you all today. Beautiful day down here in outskirts of Brisbane. A bit cooler this morning when I was up mustering our research bulls, but a beautiful day. So we better get rattling. I put my email address here because if at the end of the session you have a burning question, hasn't been answered, I'm quite happy for you to email me, and I'll definitely respond. So what are we going to cover today? We're going to be talking about Vibrio, Trich, Pestivirus, and Lepto. I've been working with the AACO stations and their staff in a project supported by Meat Livestock Australia and the University of Queensland. And we've been working on how do we go about diagnosing and controlling these diseases. So that's what I'm going to try to cover today. Now, look, there are textbooks written on this, so it's a big ask to try to cover in about 30 minutes. Let me highlight one thing, one really important point. Although outbreaks of these infectious diseases definitely do occur, more often than not, what is actually occurring is a lower level of infection, so that you don't see these dramatic, differences in pregnancy rate. For example, instead of having typically 80% of your cows pregnant, you find that there's only 40% pregnant. More often, when these infectious diseases are present in their herd, they're causing a grumbling loss. So I just need to highlight that fact to you. Now, the other really important point to appreciate is that we all looked for that silver bullet in the case of infectious diseases, a vaccine. But it's very, very important to appreciate that the causes of, for example, calf wasting, losses from pregnancy diagnosis to weaning, is multifactorial. In other words, infectious diseases most certainly can cause losses. As you can see, if you look at the right-hand side of the screen there, lower section, you can see the array of infectious diseases that can result in the birth of a dead calf. But you can equally see on the left-hand panel an array of different nutritional issues, cow issues, that can result in either a difficult birth or the birth of dead calf. All right? It's important to understand that, for example, heifers, cows failing to have sufficient milk to feed that newborn calf is a common problem. So that if you're thinking that if we just focus on control of infectious diseases, that's going to solve the problem, then I'm afraid that's completely untrue. So another key point, looking at the Pestivirus or bovine viral diarrhea virus, what we shorten it to BVDV, the venereal infections, Vibrio and Trich, and Lepto. The primary source of infection for all of these are carrier cattle, right? In other words, the biggest risk to a mob, to your herd, is the introduction of new cattle, because they could be carrying one of these for infections. Now, this map here on the left-hand panel shows the major routes of movement of cattle around Australia at any given time. And so it's important to recognise that, there are planned and unplanned movements of cattle going on all the time. And that's mobs within property, so mixing of mobs within a property, that's a potential risk for introduction of infection. Moving between properties within the same business, moving between properties within a region and interstate. So there's no question that moving of animals is a common means by which these infections can be introduced, because the infections persist in the animal. So let's get on and start some specifics about each of these infections. I'm going to talk first about the venereal infections. Both Vibrio and Trich are motile microorganisms. In other words, they have the capacity to move themselves, so that after mating with an infected bull, they enter the cervix and then they spread up along the uterine tubes and actually up into the oviduct themselves. Now I'm just going to play you a short video here in the left. Hope you can all see that. What you're looking at is the trich organisms under a microscope. So you could see there, they're moving, right? They look about the size of sperm, whereas the Vibrio organisms are much, much smaller. But again, they're motile. So, some key facts about these venereal infections. Firstly, they occur worldwide, affecting all breeds of cattle. Bulls, being a venereal infection, bulls are the major reservoir of infection. But carrier females do occur, and perhaps 1 in 10 females become carriers for a variable period of time following infection. Older bulls carry the infection for a longer period of time. They become persistently infected or chronically infected. The older bulls are much more likely to carry the infection long term than younger bulls. That doesn't mean that younger bulls can't become infected. It's just the frequency of infection in younger bulls is much less than in older bulls. Bulls infected with either Vibrio or Trich show no signs of infection, so you have no indication if you looked at the bull that it was infected with either of these infections. Mobs of bulls on a property can be infected with both Vibrio and Trich. This was demonstrated in a study some nearly 30 years ago in the Victoria River District. Both infections cause cattle to be infertile. All right, so the consequence of infection is infected females are infertile for several months. They may then become fertile again as their immune system eliminates the infection. So there may be simply a delay in conception. Other females do become pregnant and then they abort, and they typically abort for Trich between 2 to 4 months of gestation, and for Vibrio later, 5 to 7 months of gestation. So what do we see? The overall impact of these venereal infections in mobs mated for short periods is a reduced pregnancy rate. And in those mated for longer periods, or in the continuously mated herds, what occurs is that infected cattle calve about 3 to 6 months later than expected. So instead of the normal number of calves being taken off at first round muster, there'll be a reduced number, and there'll be more being taken off at the second round. So it can be quite insidious, the loss. It might not be very obvious. That's what I'm highlighting. Now, I just thought I'd show you these images of what an aborted cow looks like. So you can see in the left-hand panel the characteristic crusting of the tail, and notice the crustiness is below the level of the vulva. So that characteristic crustiness, and there's often a smell associated with it. In some cases, in the middle panel, you can see there is this characteristic yellow, thick discharge, and in some cases, as in the right-hand panel, you can see that there is actually membranes hanging and encrusted with fecal material hanging from the vulva of the cow, the affected cow. So that's what abortion tends to look like. It's pretty rare in our extensive systems to actually pick up aborted fetuses. So testing for trich and Vibrio. The general approach is collection of a tricampus sample. So you can see there in the highlighted yellow panel that ridged plastic tool that we use. It's attached to a long plastic tube, and we insert that in the sheath and rub it backwards and forth across the penis, across the lining of the sheath, to pick up the smegma, the material that gathers on the surface of the penis and lining of the sheath. That's where these organisms, that's where the trich and the Vibrio live. All right. You can also use this tricampid device to collect samples from the vagina or cervix. We then put them into a tube containing some special saline, and then we send it off for a so-called PCR test. So what that PCR test is doing is it's testing for the distinctive DNA of the trich and the Vibrio. So that's one way of confirming, right? And we particularly use this testing approach in bulls. So in fact, that's what I was doing this morning with our research bulls. Another way of confirming that there's been an outbreak of Vibrio, not trich, Vibrio in your herd, and I often do this kind of testing at the time of preg testing a herd where we've got a lower than expected pregnancy rate, is to use a long plain cotton swab and insert it into the vagina and collect some of the vaginal mucus. We can then put that into some special fluids, send it off to the lab, and they can test for the immune response to the Vibrio infection. And we use this as a herd test. Something you have to just bear in mind with this approach is that the immune response following infection in Vibrio can actually persist for well over 12 months. So in fact, you might detect it, but in fact, it might relate to an infection that occurred not this current season, breeding season, but the previous. So in the cash cow project, we found that about 50% of mobs had evidence of Vibrio infection. And that study, as you can see, the red, yellow, green, blue dots are the commercial cattle properties that were enrolled in the cash cow property. So right across Northern Australia, we're talking about 50% of mobs had evidence of Vibrio, and about 10% had evidence of an outbreak of infection. So that gives you a feel, of the how common Vibrio infection is, and almost certainly trich infection. So let's have a look at trich. We didn't have an opportunity to look at trich in the cash cow project, but after the the project was finished, myself and researchers from Murdoch University and from the University of Queensland conducted a study primarily based at a large abattoir in southeast Queensland, and we collected samples from bulls at slaughter. And you can see in this map we've inserted the frequency by postcode of bulls that we found infected with trich. All right, and you can see across the north of WA, the NT, North Queensland, you're talking about 1 in 10 to 2 in 10 bulls were infected. Further south from there, the rate of infection was less. It was more like 1 in 20. Please note that there was evidence of infection in the northwest of New South Wales. I guarantee you that there is infection with trich that now, because of the movement of cattle, there's very likely that there is trich infection in herds further south. On the left-hand panel there, that wonderful picture of the trich organism itself, right? You can see those long flagellae and folds on the animal, on this microorganism. That's how it can move around, as you saw in the video clip. So stations with 30% of bulls that are trich positive are common, unfortunately. So that trich has been around, as has Vibrio, since the 50s. So looking at the current control of these venereal infections, for Vibrio we have a vaccine. So the first step in control is vaccination of bulls. They need 2 shots initially, all right? But there's flexibility, you know, between the first and the second. It can be up, it should be at least 1 month apart, but it can be up to 6 months apart. Key thing is that you should aim to give the second shot 1 to 2 months before start of mating. In other words, so they go into the mating period with maximum protection. Thereafter, bulls need an annual booster. When to do your annual boosters? Target that annual booster to occur just before start of mating, about 1 month, 2 months before start of mating. Now, an interesting thing about the vaccine is that if bulls are already infected with Vibrio, vaccination alone will eliminate infection in about 90% of infected bulls. That means that it's not effective in 1 in 10 bulls. Bear that in mind. Now, thinking about heifers, all right, and heifers, you know, you want to give them the best start. They're the future of your herd. You want them to calve down over a short period. So increasingly, we are recommending vaccination of heifers. Bull control across Northern Australia is problematic. So the recommendations for vaccination of heifers, it depends on the age when you first make them. If they're yearlings, they'll need 2 shots. If they're typically 2-year-olds, they'll only need 1 shot. Unfortunately for trich, there is no vaccine. That's what I was working on this morning with the University of Queensland team. We're working on developing a vaccine. That's going to take us a few years to get to a commercial vaccine, but we are working on it. So going forward, before we have a vaccine, the approach is test and cull infected bulls. So using that tricamper device, the AACO team that I've been working with have been conducting large-scale testing. How many can you get tested in a day? Testing 500 bulls in a day is quite possible. The big issue with regards this test and cull program is getting clean musters of bulls. Now, I think you all understand the problem of getting clean musters with older bulls. They are a headache, but they are a reservoir of infection. If you maintain a young bull herd, right, so that you bring bulls in, mate them as, e.g., as yearlings or as 2-year-olds, mate them for 4 years, and then strictly tip them out, then that's going to help because they have this natural resistance to infection. Maintaining good biosecurity. Only purchase replacement bulls that have been vaccinated. I've always said to people worry about lumps. I like lumps because it tells me if I can see 2 lumps, the bull's been vaccinated for Vibrio. Trich test new bulls, particularly mature bulls. So, changing gears, we're going to talk about Pestivirus. Now, in the cash cow project, we found that about 10 to 30% of cow and heifer mobs annually had evidence of an outbreak of infection. All right, so that's a pretty big number. Now, let's dispel a couple of myths. One of the common myths is Pestivirus is everywhere and most cattle eventually become immune. Facts are about 1/3 of heifer mobs out there now have no natural immunity at all, right? They are sitting ducks. They are at risk of an outbreak, as we showed in the cash cow project, where we showed 10 to 30%, in some years up to 30% of heifer mobs experiencing outbreaks. And it occurs in these mobs that just by chance have not been exposed to a carrier animal, to a persistently infected carrier animal, and have no immunity. About 1 in 10 herds out there are completely susceptible, right? So here's an important take home. To manage Pestivirus, you've got to have a good understanding of your herd's natural immunity status. Now, infection of a naive female between about 3 weeks and 5 months of gestation can result in the birth of a calf persistently infected with Pestivirus. These animals are the primary source of infection in herds. About 1 in 200 animals walking around out there across northern Australia are persistently infected with Pestivirus. Now, the life expectancy of these PI animals is shorter than normal. Most are dead within 2 years of age, but some live to 10 years or more and appear completely normal. Now, in situations like this, so on the left-hand panel, we've got a mob that's been mustered, e.g. for weaning, pregnancy diagnosis, etc. In these close contact situations, if there was a PI present, then you can get quite rapid transmission. In studies we've done on multiple occasions, we've demonstrated that up to 60% of susceptible animals can become infected in these close contact situations. Imagine if you're conducting an AI program and inadvertently you've got a persistently infected female in there, you can get quite rapid transmission because you're regularly handling those AI animals, all right? Another means of transmission that is much more common than people realise is over-the-fence transmission, because you only need direct contact for about 1 to 2 hours, because these with a persistently infected animal, because these PI animals are shedding millions of virus particles in their saliva, for example, or their tears. Another myth, all PI cattle are poor doers. Yes, this poor unfortunate in the upper left-hand panel is a PI. You would pick that one. all right? And in the lower right-hand panel, you'd say the animal walking to the right, yeah, that's a PI. What would you say about this lovely-looking bull that was presented? Is that a PI? Well, you cannot tell unless you test it. I've had grand champions at the ECA, at the Royal Easter Show, in AI centres that were shown to be persistently infected. In fact, in this right-hand lower panel, every one of these animals are persistently infected. What happened was a producer inadvertently placed a persistently infected heifer in with a mob that he was mating. They were all approximately 1 to 2 months pregnant when he added a few extra heifers, and a whole bunch of them became infected, and 17 persistently infected calves were born. Introduction of pregnant females is very risky, all right, because they might be carrying a persistently infected fetus, so-called Trojan horse. You've seen what cows are like when they give birth. There's much sniffing and licking and carrying on. Perfect way for transmission to occur. If you've got females that are already being mated, early pregnant, then transmission can occur and damage can occur. Following infection with pestivirus, the virus can persist in the reproductive tract of both males and females for at least 6 weeks. All right. So here's a really important take home for you. There's lots of people use in AI programs custom collected semen. I always ask the question, did you test the bull and verify that it was not persistently infected with pestivirus before you collected and froze that semen? All right, just bear that in mind. Also, pestivirus can survive in slurry and manure for several weeks, particularly in cooler, moister conditions. So, this is important with regards, contamination via poorly cleaned trucks, etc. Transmission can occur occasionally via these wretched things, our friends the buffalo fly. It could be a means by which the virus, the persistently infected animal is in one paddock and you've got a bunch of these flies on them, and then they migrate across to the paddock next door onto some cattle there, and that might be how transmission could move from one paddock to the next. Here's an important issue. Too often people will say to me, yeah, we've done some testing and we found that 50% of them or 60% of them were infected. I always ask the question, so did you test each mob? Oh, no, we just tested one group. And the problem there is you cannot, by testing one group in your herd, make any conclusion about the rest of the mobs. Here is an example. In this station, all of the cattle in 7 paddocks, a cross-section of animals were tested to determine what proportion had been infected and were now naturally immune. And you can see that there's huge variation, right? You've got paddock 3, no evidence of infection. You've got paddock 6 and 7 with very low rates of immunity, and paddock 6 and 7 right beside a mob in paddock 5 where there may well be a persistently infected animal because they've got a high proportion of animals that have been exposed. So you can see here the problem when you start mixing animals. If you were to take animals out of paddock 5 and put them into, let's say, paddock 3, and inadvertently you've moved a perfectly normal looking persistently infected animal, right, into paddock 3, you could initiate an outbreak of pestivirus infection in that paddock. So to get a true picture of what's going on in your herd, you have to do a cross-section of each of the breeding management groups in the herd. So I can see I'm running slightly short of time, but we're going pretty well. I'm not going to go into huge detail about all the things that pestivirus can do, but believe me, it particularly affects the early stages of development. So fertilization, early embryo development, early development of the fetus, it can be particularly savage on those. And that can result in either females returning at the normal expected time back to heat, or having a prolonged interval. It can cause abortions and stillbirths and premature births, birth of weak calves, abnormal, poor-doing calves. It can cause, because it can result in the birth of persistently infected animals, they can go on to develop mucosal disease, or they can develop severe manifestations of common diseases like rain scald, very severe rain scald, that don't respond to treatment. In feedlots in particular, but also in weaning yards, if there's a persistently infected animal in there and many other animals become infected, then one of the big problems is infection can seriously reduce the effectiveness of those animals' immune response. So they are more susceptible to, for example, other infections that cause respiratory disease or scours, all right? So it can predispose to those other common infections. To detect a persistently infected animal, you firstly got to have evidence that there is one present. That might be you've got from your testing for have they been exposed. You might have a high prevalence of infected animals. You then go in and you test hair samples or skin notch samples from every animal to identify which one is persistently infected. To confirm a PI, you need to test them twice, right? An animal that's been infected after birth won't become persistently infected, and if you tested them, they might be virus positive on the first test, and then on the second test, they'll be virus negative. Whereas the persistently infected animal, you test them first, second, third, and so on every time they are virus positive. To define the immune status of any mob, you need to take a cross-section of animals. Don't bleed the first 30 or the last 30 up the race, right? Bleed a genuine cross-section, 15 to 30 animals, and that will tell you what proportion have been exposed to pestivirus or not. So some graphic pictures of what mucosal disease can look like. If you open the mouth on the animal on the left-hand panel, you might panic because you might think that's the dreadful foot and mouth disease. More commonly, you see this problem on the right panel of just localized ulceration. So the options for controlling pestivirus: do nothing. If your testing shows that most females are naturally immune, good. You can improve your biosecurity by ensuring that, for example, all the bulls that you buy have been tested and verified as not being PIs. You could go through a test and cull program to remove persistently infected animals, but then you've got to remember that over time, your herd will become completely susceptible. And therefore, you are a sitting duck, right? Unless you've taken extreme steps to prevent any contact with outside cattle. You could, and in the past, and unfortunately probably continuing, people, before we had a vaccine, we did some of this work. You could expose your heifers to a persistently infected animal to induce natural immunity. The problem is people forget. They forget that animal sitting in that small paddock there is a persistently infected animal. So they bring their pregnant females past and they all have a good chatter and transmission can occur, right? It's a risky business. And the other thing is you're all set up with your PI animal exposure, and then, as I said, they die prematurely. So now what are you going to do? It's dead. Vaccination. We do have an efficacious vaccine. We've done the testing of it. We know that in a situation where there is very intense exposure, in other words, the females are in direct close contact with a persistently infected animal, that it will protect about 80% of those females from infection. In a situation where there's intermittent contact, it's 100% protective. The key thing here, again, if you're going to vaccinate, they need two vaccinations initially, 1 to 6 months apart. It can fit in with your routine musters, and you need to, but the key thing is you must ensure that the second vaccination occurs prior to the start of mating. I've seen people who have vaccinated once before mating and then again a preg test. That's not giving good protection. You need to do both prior to their first mating. That's whole herd vaccination, not commonly done. I generally recommend vaccination of heifers only, because that's the group typically that has the lowest proportion of immune animals. That's the group that you want to have carved down over a short period of time. I want to say a few words about lepto. When I first came up into Northern Australia, any reproductive loss problem was blamed on lepto. The reality now is that, as we found from cash cow, only about 10% of mobs had any evidence of recent infection with the two common types of lepto, leptoharjo and leptopomona. All right? They're the two that are protected by the vaccine. The problem is there are about 21 other types of lepto out there, and rodents, feral animals, wildlife are important sources. What we've demonstrated through some of the research from our group is that leptoharjo in particular has become primarily an infection where the animal's kidney becomes infected, but there is no evidence of reproductive loss. In other words, it's become a parasite of the kidney of these animals. Now, you need to understand that lepto, again, it's able to move. It's one of these moving bacteria. It can survive for several months in wet, muddy conditions. It can be transferred via waterways from one site to another. All right? The main source of it is urine from infected animals. And when cattle become infected, right, they'll stay persistently infected for some months, all right, shedding that harjo or pomona or one of these other types of lepto. Infected cows usually show no signs of infection. They may abort, all right, much less common now than in the 60s and 80s. We still see from time to time this problem of deaths in calves, all right, where they show signs of anemia, red urine, all right? They might show signs of being weak, poor doers. Key thing about lepto is you've got to understand that humans can become infected. So if a person working with these animals comes in contact with that urine contaminated mud, water, picking up an aborted fetus from milk, contact with an infected placenta, that they could become infected. And lepto in humans is nasty, right? So the main reason we recommend vaccination of cattle for lepto is to prevent infection in people of those common types of lepto. Also important, there's been reports of people working in cattle yards, muddy conditions, bare feet. I'm telling you now, that is really dangerous because there is a real risk. Lepto can get into cuts in your feet, hands, urine splash into eyes. Nasty condition to have. I'm just going to finish here. This just shows that vaccination of bulls against Vibrio, about 2/3. Use of vaccination for control of the other infectious diseases is pretty low across Northern Australia. One of the problems is that people think that if they vaccinate their cattle, they're going to get an improvement in reproductive performance. That may occur, but that is not a common outcome. The reason you vaccinate is to prevent an outbreak of infection. That is, you are buying insurance. Thank you very much for your attention. I'll take questions. And as you can see here, all right, proof, eating salad all day does not make you skinny.